triangle's midpoint and distance formula. The Pythagorean theorem in any right triangle, if A and B are the legs of the right triangle and C is the length of the hypotenuse, then A squared plus B squared equals C squared. All right, so A and B, they're the legs. These are the sides of the 90-degree angle. That's what we call the legs, and the hypotenuse is the side opposite the 90-degree angle. So remember, principal square roots are always positive answers, so these answers are lengths of the sides of a triangle. They have to be positive. So solve for the missing side. Okay, A will be 10, B will be 90. We're looking for C. A squared plus B squared equals C squared. Plug in the 10 and the 90. We'll square them to get 100 plus 8,100 to get 8,200. Take the square root of both sides. Now, in the homework, you got to watch your directions here. The directions, if they ask you for the exact value, that means they want you to simplify the square root of 8,200 and leave it in radical form. If they want the decimal version, then go ahead and take the square root of 8,200 and round it to wherever they tell you. I will tell you this. On the test, I prefer exact values. All right? I don't like decimals because everyone's going to round to the wrong decimal, and then I got to check things over. I prefer exact value answers, and you will see that in the directions. If I want a decimal answer, I'll ask. If I want exact value, I will state it. Special right triangle, the 45, 45, 90 is made from a square. Of course, it has 4 right angles and 4 equal sides. To make your rectangle, we are going to cut it in half diagonally. Now, this builds my right triangle. That line cuts the two 90-degree angles in half at 45 and 45. So here is my special right triangle. Now notice the two legs are both B. Using the Pythagorean theorem, we can solve C, put in a B squared for A squared. That's 2B squared. Take the square root of both sides. The square root of B squared is B, and the square root of 2 is the square root of 2. Now C is written in terms of B. All 3 sides have the variable B. So what we want to remember is this triple ratio of the angles, 45, 45, 90. Then the sides opposite of those 3 angles are B, B, and B square root of 2. So if we were asked to solve for X and Y, right now, you cannot assume that this is a 45, 45, 90 until they put something in here. So I'll put in the 45, and now you only need 1 because this is going to be 45 degrees too. So then we'll put in our B's. Come on, mouse. B equals 6, B equals X, and B square root of 2 is equal to Y. So X is equal to 6. Y is equal to 6 square root of 2. You may also see from your geometry days those congruent arcs. These are both equal angles, which means they're both 45. So therefore you can put in the B, B, and the B square root of 2. Well, 8 equals to the B square root of 2. We've got to solve for B, divide over the square root of 2. Whoops, we're going to have to rationalize that by multiplying by square root of 2 top and bottom. Because remember, we don't want to have a square root symbol in the denominator. So that's going to be 8 square root of 2 over 2, and 2 goes into 8 4 times. So all my other 2 sides, X and Y, are going to be 4 square root of 2. Our second special right triangle is a 30, 60, 90, which is made from an equilateral triangle, which has 3 angles that are 60 degrees and all sides are equal. But in this case, I'm going to put 2A, because to make my 90-degree right triangle, I have to cut this 60-degree angle in half up here with a perpendicular straight line. So 30, 30, now that cuts 2A into A, and my vertical line will be B. So here's my 30, 60, 90 right triangle. And C has an A in it. Here's an A. Now let's solve for B. So we're going to have A squared plus B squared equals 2A squared, which is 4A squared. We'll subtract over the A squared to get 3A squared. To solve for B, we'll take the square root. So the square root of A squared is A. Square root of 3 is square root of 3. And there's our B value, and all 3 sides have an A in it. That's why these are special right triangles. Let me rephrase that. Remember, the Pythagorean theorem stated you need to have 2 sides of a right triangle to find a third. In these special right triangles, you've noticed you're only given one side, but you can find the other two. So my 30, 60, 90 triple is going to be A is opposite of 30, A square root of 3 is opposite of 60, and 2A is opposite of 90. All right, so solve for X and Y again. They have to give you either a 60 degree up here or a 30 degree angle down here, or they can give you both, but it needs to be there. You can't assume it's a 30, 60, 90. So A will be the 8, X will be the A square root of 3, Y will be the 2A. A is 8, let's put it into the other two sides. X is 8 square root of 3, Y is 16. All right, our 30, 60, 90 here, so A will be the Y, A radical 3 will be the 12, X will be the 2A. Here's the equation to solve for. Divide over the square root of 3, realize I have to rationalize my denominator by multiplying top and bottom by the square root of 3. That's going to give me 12 square root of 3 over 3, and the 3 goes in 12 4 times. So A is 4 square root of 3. Then we'll come over here for X and multiply 2 to the 4 and make it 8 square root of 3. Now, knowing these triple ratios or triple proportions, you don't even need to have a triangle. They can just give you a table. So if I started the 30, 60, 90 here, A goes in my column, 60 is going to have A square root of 3, and 90 is going to have 2A. So here, first row, easy money. A is 9. Then this blank is 9 times the square root of 3 centimeters. This is 2 times 9, 18. Second one, okay, we got a little work here to do. A square root of 3 is equal to 15. Divide by the square root of 3. Rationalize it. 15 square root of 3 over 3 is 5 square root of 3. Double it to 10 square root of 3 for 2A. Third row, 12 is 2A, which means A is 6 centimeters. And opposite the 60 will be 6 square root of 3 centimeters. Last row, 4 square root of 3 is my A square root of 3, which means A is 4 centimeters, and 2A is 8 centimeters. In the 45, 45, 90, B square root of 2, these two columns always have to be the same answers. So if this is 7, this is 7, and then this is 7 square root of 2. If this is 10, this is 10, and this is 10 square root of 2 centimeters. If this is 12, divide by the square root of 2, rationalize. 12 square root of 2 over 2. 2 goes into 12 6 times, so 6 square root of 2 for these two. B square root of 2 is equal to 8 square root of 2, so B is 8. They're both 8 centimeters. Our distance formula and midpoint. The distance formula between any 2 points in the xy coordinate plane can be derived by making a Pythagorean theorem right triangle. So if I build a right triangle, put a horizontal through one point and a vertical through the next, that point of intersection is where my 90 degree angle will be at. Let's call that C. This is going to be point C. So here's A, here's B, there's C. Now, we'll call C D for distance. We're looking for the distance between those 2 points. The coordinates of C, capital C here, this vertical line through B, x sub 2 has to be the same down here in C. This horizontal line means that y sub 1 has to be the same. So now A, it's the distance between these two y coordinates, y sub 2 minus y sub 1. B is the horizontal distance between these 2 points, x sub 2 minus x sub 1. And now we go to the Pythagorean theorem and plug in those binomials. A, y sub 2 minus y sub 1 will square that. B was x sub 2 minus x sub 1 will square that. And C was D, so we'll call it D squared. So my distance formula is simply take the square root of both sides, and there it is. Now, some books will get the x's first and the y second. It doesn't matter. The other thing I want to point out, which is super important here, is that these always have to be positive numbers because you're squaring them. So one thing I like to do, I won't do it in my videos because I have to be mathematically correct and follow the formulas, but the way I like to do this, biggest x coordinate minus smallest x coordinate, biggest y coordinate minus smallest y coordinate, positive, positive, square a positive, it's positive. All right. example, up next, midpoint. Midpoint is the average between these two coordinates. So to find the average between two x's, you add the x's and divide by 2. To find the average y coordinate, you add the y's, divide by 2. That's the midpoint. All right, let's find the distance and midpoint between -3, 5, and 9, -11. Here's my distance formula. X sub 1, y sub 1, x sub 2, y sub 2. All right, for my x's, 9 is bigger than -3, so 9 minus a -3. Okay, now if this was me working it on myself, looking at my y values, 5 is bigger than a -11. I'd go 5 minus a -11 to get a positive 16 here. All right, that's more important to me. Because if you type in a -16 without the parentheses and you square it, you get a negative value, and that will throw things off. So let's just make it positive. 144 plus 256 is 400. The square root of 400 is 20. We're done. Our midpoint, all right, take the two x's, add them together. -3 plus 9 over 2. 5 plus a -11 over 2. We're going to get 6 over 2, -6 over 2. 3 comma -3 is my midpoint. All right, if m is 3 comma 7 and it's the midpoint of segment AB, find the location of B when A is located at -6, 10. All right, every author wants you to take 3, 7 and set it equal to the midpoint, and then say plug in the -6 for one of your x's, the 10 for one of your y's. Done it. Make two equations. This x coordinate equal to this x coordinate, this y formula equal to that y, and solve this. And either way, you have to multiply. Whichever one you want to solve first, no matter what, you got to multiply both sides by 2. So do them both at the same time. 3 times 2, 6, 7 times 2, 14. Add over the 6, subtract over the 10. 12 and 4. That's the other endpoint. Now, I'm all for keeping things easier. All right, based off of our work, let's make a shortcut. Start with the midpoint. You had to double the 3 and the 7 to get 6 and 14. Okay, times 2, 6 and 14. Look at the least amount of work just to get to the 6 and 14. Now notice, what did we do next? We took the -6 and the +10, and we took their opposites to the other side. What that means? Subtract the given endpoint. Minus -6 minus 10. Minus a negative becomes a +6. 12, 4. Look at the amount of work compared to all this. Keep it simple. All right, and that wraps up 10-7.